Okay, take a look up tonight if you can. At the moon. You see it all the time, but beyond that familiar glow, our closest neighbor in space holds, well, a universe of scientific secrets. Today we're diving deep into some really cool NASA insights. We want to uncover how the moon really profoundly shapes our understanding of, the whole solar system.
That's absolutely right. This deep dive is all about unpacking the incredible data coming from NASA sources. We're focusing on the moon's pivotal role. It's not just about lighting up our skies, as you said. It's actually a critical key to studying Earth itself and the wider cosmos, too. From how it formed, which is quite a story, to the very latest discoveries. It's a real treasure trove.
So our mission today really is to guide you pretty swiftly through the moon's fascinating characteristics, some recent findings, and how it keeps shaping our view of the solar system. By the end of this, we hope you'll see our celestial companion a bit differently, understand its impact. So yeah, let's jump in.
Okay, so the moon is much more than just a pretty sight in the night sky. It's real significance. It's not just the light, it's this incredible ability it has to preserve evidence of our solar system's, well, pretty violent history. It's like a time capsule, literally, which makes it crucial for understanding our own planet and everything else out there.
Right. And one thing people often wonder about, or maybe get wrong, is the atmosphere. Does the moon actually have one? What's the deal there?
It does, yeah, but just barely. It's what scientists call an exosphere, and it's extremely, extremely thin. NASA has this great analogy. Think of the haze you get when you, whack a really dirty rug with a broom.
Okay, yeah.
It's kind of like that. But instead of dust bunnies, it's individual particles getting knocked free from the moon's surface. They get ejected into, well, almost total emptiness because the moon is constantly getting hit by tiny bits of space debris.
Huh. So it's not like a protective blanket like Earth's atmosphere at all. More like it's constantly sort of shedding. Does that mean it's losing mass over time, or is that effect just tiny?
It is shedding material, yeah, but the actual mass loss is pretty negligible over, astronomical timescales.
What's maybe more important for a study is what isn't shed or worn away. Like the surface itself, it's famously covered in craters, right?
Yeah.
What can those tell us beyond just, hey, something hit here?
Oh, they're incredible historical records. But it's more than that. They actually help us understand other worlds, too.
Right.
See, because the moon doesn't have liquid water, or really anyone to speak of, there's no erosion to wipe away the evidence.
Right.
So its surface has basically kept this pristine record of impacts going back billions of years. By looking at how many craters there are, how big they are, we can actually build a timeline for impacts across the entire solar system. This helps us figure out the age of surfaces on places like Mars or Mercury, where we can't just go grab a rock easily.
Wow.
Yeah, and NASA's Lunar Reconnaissance Orbiter, or the LRO, it's given us these amazing high-res maps. We can see details down to 1 meter, specific craters, like the Perazzo crater in incredible detail. Using our moon as a clock for the whole solar system, that's amazing. And it all kind of goes back to how the moon even got there in the first place, which wasn't exactly peaceful, was it?
Not at all. The main theory, the leading one anyway, is that our moon was, and this is a great phrase, born out of destruction.
Yeah.
The early solar system was just chaos, a shooting gallery, basically. Violent smash-ups happening all the time. And these collisions, they could either totally obliterate things, or sometimes they'd lead to creating new, bigger objects. Things got mashed together, forming the planets and moons we see today. Our moon is basically a giant piece of evidence from that violent era.
A dramatic beginning for sure.
Okay.
And it created this really unique world, and it's this ancient but still dynamic moon that keeps up this incredible dance with Earth. It shapes our planet in ways we actually experience every single day.
Yeah.
Maybe we should dig into some of those interactions, like something everyone sees, the moon phases. What's actually going on when we see the moon change shape?
Yeah, definitely. What you're seeing is just our perspective changing. Earth's view of the part of the moon that's lit by the sun, which is always half of it,
right,
shifts as the moon orbits us throughout the month.
Yeah.
So we see that pattern, the 8 lunar phases. You start with the new moon, then waxing crescent, first quarter, waxing gibbous, the full moon, of course, then waning gibbous, third quarter, and finally waning crescent before it starts again. NASA's even got this cool visualization coming for 2025 showing the phase changing hourly. Really shows how constant that movement is.
And sometimes that constant dance lines things up just right for, well, eclipses, these amazing celestial events. What's the simple explanation for those?
Right. From Earth, we see 2 main kinds, lunar and solar. Basically, an eclipse happens when the Earth, Moon, and Sun line up perfectly, so one of them casts its shadow on another. In a solar eclipse, the Moon gets between us and the Sun, blocking the sunlight, creates that temporary twilight. In a lunar eclipse, it's the other way around. Earth gets in the middle, and our shadow darkens the Moon. Sometimes makes it look reddish. It's like cosmic shadow puppets.
Cosmic shadow puppets, I like that. And it's not just shadows, right? The moon has a real physical pull on us, affecting our oceans.
Absolutely, the tides.
Yeah.
Even though it's so far away, the moon's gravity plays this huge role in creating Earth's ocean tides. It's a constant physical reminder of that connection between Earth and moon.
It really is. Now, speaking of connections and maybe surprising things, what's the latest on water on the moon? That's been a big question for a long time, hasn't it? The answer seems to have changed a bit.
It really has evolved, and yes, it's now confirmed. There is water on the moon, and actually in more than one form, which is fascinating. Yet we know there's ancient ice hidden deep down in craters near the poles that are permanently shadowed. Sunlight literally never reaches the bottom of some of them.
Wow, permanent shadow.
Exactly. But even more remarkably, scientists have found H2O molecules, water molecules, just sitting right on the sunlit surface too. Not like puddles, but bound to the minerals. People have been looking for lunar water for, well, hundreds of years in some ways. But now we have actual maps, thanks again to LRO data, showing where we think water ice deposits might be, especially concentrated at the moon's south pole.
And that's huge for future exploration, isn't it? I mean, if there's water...
Oh, it's a total game changer. It means future astronauts might not have to haul all their water or even the oxygen you can get from water all the way from Earth. We could potentially mine these resources on the moon. That makes setting up long-term lunar bases or even using the moon as a stepping stone to Mars much more feasible, cheaper too.
Yeah, that makes a massive difference. Okay, let's tackle another common idea. The dark side of the moon. People always say dark side, but that's not quite right, is it?
No, it's a really persistent myth. The moon's far side, the side we don't see from Earth, actually gets just as much sunlight as the near side does.
Ah, okay.
Think about it. Like Earth, the moon rotates. It has a day side and a night side, and those change as it spins. The sun always lights up half the moon. It's just the same half always faces us. That's due to something called tidal locking.
So it's the far side, not the dark side.
Exactly.
Yeah.
And LRO, again, has mapped the entire surface, near side, far side, everything, down to that incredible 1-meter scale. We've seen it all in amazing detail now.
Okay, got it. Now, you mentioned moon dust earlier and how it's a challenge. When I think of dust, I think of, stuff you wipe off a shelf. What makes moon dust so difficult for explorers, human or robotic?
Yeah, it's way more than just a nuisance. It's not like Earth dust at all. Lunar dust particles are incredibly abrasive. They're sharp, jagged, almost like tiny shards of glass.
Ouch. Why is that?
Because they've never been weathered down by wind or water like dust on Earth.
Yeah.
Plus, they carry an electrostatic charge from the solar radiation, so the dust just clings to everything. Spacesuits, equipment, visors, seals. Astronaut Gene Cernan famously called it like dirty snow, but a snow that gets into everything and causes major problems. It can wear down machinery, clog up seals, block cameras, and it's even a potential health hazard if astronauts breathe it in. It's a really serious engineering challenge for future missions.
Wow. Okay, definitely not just household dust. So a fundamental hurdle. And one last thing about the moon's geology, volcanism. Was the moon ever active like Earth? Are there volcanoes erupting now?
No, definitely no erupting volcanoes today. The moon is geologically much quieter now. But we have overwhelming evidence that it was once flooded with flowing lava.
Ah.
Those dark patches you can easily see on the moon, the seas or Maria, those are vast plains formed by ancient volcanic eruptions. Huge flows of lava filled in giant impact basins billions of years ago. So yes, it had a fiery past, but its volcanic phase is long over.
Okay, so we've covered its past, its present features. What about the future? How is all this knowledge feeding into what we're doing now with moon exploration?
It's a really exciting time, actually. Things are moving fast. Just recently, NASA picked the instruments that will go on the Artemis program's lunar terrain vehicle. That's the new moon buggy astronauts will drive. Super important for mobility.
Right.
There are also updates on something called PRISM, that stands for Payloads and Research Investigations on the Surface of the Moon. It's basically NASA sending lots of different science experiments to the moon using commercial landers. It helps get science done faster. And efforts are underway to recontact the Lunar Trailblazer mission. That's a small satellite designed specifically to map water on the moon in detail. And LRO is still up there, sending back amazing data, like it recently imaged the impact site of that ISS-based Hakuto R lander attempt.
Lots going on. It feels like the moon is really back in focus.
Absolutely. And, after this deep dive, you might feel inspired to look up at the moon a bit more closely yourself tonight. And NASA actually has some great resources to help you do that.
Oh, yeah. Like what?
Well, there's the Daily Moon Guide on their website. It's this cool interactive map that shows you what the moon looks like, its phase, for every single day of the year, help you track it.
Nice.
Or, if you want to be a bit more hands-on, they have a moon observation journal you can download. It guides you through observing it over a whole month, really getting to know its features.
And isn't there like a big event, too?
There is. International Observe the Moon Night. It happens once a year, usually in the fall. People all over the world observe the moon together. You can even share your observations using the hashtag #ObserveTheMoon. It's a really neat global thing.
Very cool. Easy ways to connect with it personally.
Definitely. So wrapping up, we've covered a lot today. Hopefully we've given you a clearer view of the moon's makeup, its pretty violent history, its current state water ice and tricky dust included, and all the discoveries still happening.
Yeah, from that destructive birth billions of years ago to finding water molecules on the sunlit surface today. It's quite a journey, and what's really fascinating, I think, is how the moon, this constant companion we see all the time, just keeps revealing these surprising secrets. And every secret doesn't just teach us about the moon, it deepens our understanding of Earth, and it really shapes where we're going next with human exploration. Makes you wonder, doesn't it? What else is it preserving up there, just waiting for us to find that could, change everything again?